brand new recorder, and it works awesome. You can hear me really well. In fact, you can hear you too. So anyway, it works. It works really well. So you should have no problem hearing me now if you watch the videos. Okay? Even when it's, even when it was on before, it was hard to hear me sometimes. But now the sound's pretty good. Okay? So it should work. All right. 25 pi over 180, and then 25, what number goes into both 25 and 180? 5. So it goes 5 pi, I believe it goes into 180 36 times. Is that correct? Okay, so I want you to leave it in terms of pi. So don't give me a decimal. Riker, come sit right here today. Okay, 5 pi over 36. Number 2, convert 8 pi ninths to degrees. Well, we learned to change radians to degrees, we multiply by what? 180 over pi. Okay? Now, at this point, the pi's will cancel out, and 9 will go into 9 once, so we'll go into 180 20 times. And so we get 8 times 20 is 160 degrees. Okay? And that was the answer for that one. So to change radians to degrees, we times by 180 over pi. Everybody that wasn't here, hopefully you got that. Any questions on these two problems? I'll just tell you on the quiz today, the one that we have on the quiz, you're going to end up with point something. Okay, it's just one number, so just so you know, 1 decimal place is all it's going to come out to be. It's a nice rational number. Okay, number 3. Find the cosine of 11 pi over 6 on the unit circle. Well, earlier in the year, I taught you how to do this with degrees. So now we're going to do this with radians. What did it say? 11 pi over 6? Okay, so if you guys will notice, to get to 11 pi over 6, we go all the way around the circle to 11 pi over 6. Okay, and the cosine, everybody get out your foldable. What does it say cosine is defined to be on your unit circle? No, on the unit circle. X over 1, which is just x. It's the x coordinate. Well, what is the x coordinate right here? Squared 3 over 2 is the x coordinate, right? So the answer to this one is just the square root of 3 over 2. Now, any questions on that? Okay, now the fourth problem right here, it's like that except for we have a 17 pi over 4. That's going to be more than one trip around the unit circle. In fact, I would like you guys to all take 17 and divide it by 4. How many times does 4 go into 17? 4 times with how many left over? 1. So we're going to rewrite this as 4 and 1/4 pi. Okay? 4 and 1/4 pi. So what we're looking for is the sine of 4 and 1/4 pi. Let me show you how to find that on the unit circle. Okay? Every time you go halfway around, how many pi is that? That's 1 pi, right? So we're going to start right here at 0, 0, and we're going to go 1 pi, 2 pi, 3 pi, 4 pi, and 1/4 of pi is right here. And what was it? Sine? Yeah. Sine is defined to be on your foldable, on the unit circle, is defined to be the y coordinate. So square root 2 over 2. So this one is going to be the square root 2 over 2. Okay, any questions so far? Now, you guys, I just give you a hint. I would pull out this because there are a few mistakes on that one, and I haven't really looked at that one very closely. Not only that, but sometimes the numbers aren't written right by where they should be written. So I would probably pull out this. This is more accurate. So if you've got that somewhere, pull it out. Okay, last problem. Last problem right here. Find the length of an arc given its central angle is 4.5 radians and radius is 9. Last time I gave you a formula for arc length. the formula is S equals R times theta. S stands for what, everybody? Arc length. R stands for what, everybody? Radius, not radians, radius. And theta stands for what? The measure of the central angle in what? Radians. Don't forget it has to be in radians. Okay? So, on this problem, it tells us what the radius is. It's 9. The central angle is 4.5 radians. So all you have to do is times them together. What does that come out to be? 40.5 units, whatever the units is. It doesn't say inches or centimeters or whatever, did it? So you just write down the units. Now, before we take the quiz, I'm going to give everybody a chance. Are there any of these problems you would like to ask questions about? If you don't write units, on the one on the quiz, I tell you what the units are. Okay? You ready? Okay, I would probably get a piece of paper between you and your shoulder partner, tear it, and fold it in half and tear it. You only need a half piece of paper for this. And there's no talking right now. Here's your quiz. Please write Precalc quiz 6-1 on it. These are going to be worth 2 points each. Okay, number 32 on the assignment is the tangent of 14 pi over 3. We are supposed to evaluate that. Is that right? Okay, so once again, we're going to have to divide 3 into 14. How many times does 3 go into 14, you guys? 4 with how much left over? 2/3. So we got to go to 4 and 2/3 pi. So I go over here on my unit circle. I got 1 pi, 2 pi, 3 pi, 4 pi, and 2/3 pi ends up right here, right? And so the tangent is defined to be y over x. Well, y is square root of 3 over 2, and x is negative 1/2. So square root of 3 over 2 divided by negative 1/2. That's what tangent is defined to be. Right? How do I simplify that? Nope. Yeah, you would times the top fraction by the reciprocal of the bottom fraction. The 2's cancel out, and you get negative square root of 3 over 1, which would just be negative square root of 3. That's how you do that one. If you put 1.7, it will be wrong. It will also be wrong on the test. I want exact values on this, and that has to be in terms of the radical. Okay? There are certain problems on the test that I might ask you to do using the calculator. But anytime I give you something in radians in terms of pi, I want the answer in terms of a radical. Got that? Does that make sense? So I don't want you putting in your calculator and getting it, okay? Any other questions? 40? Okay, number 40. Who needs to go? Oh, hurry, Max. Okay. The diameter of a circle is 22 inches. If a central angle measures 78 degrees, find the length of the intercepted arc. So we have a circle. It has a diameter of how much? Did it say 22 inches? Which means it has a radius of what? What's the radius? 11 inches. Okay. And it also has a central angle of 78 degrees. Okay, before I need two things to calculate this. What are the two things? Radius and angle and radians. Do I have them both? No. What do I need? I need the angle in radians. How do I do that? 78 times pi over 180. Now, what does that reduce to? 13 pi over 30. So 6 goes into 78 13 times? Yep, it does. Okay. All right, so 13 pi over 30. So now, to find the arc length, S equals the radius times 13 pi over 30. What's 11 times 13? 143. So the answer is 143 pi over 30. Now, the book might have given this answer as a decimal, did it? Oh, it is? So let me see what my book gave. Yeah, mine changed it to a decimal. So just go 143 times pi divided by 30. 14.97? Okay, 9.8 if you round it to the nearest hundredth. 14.97. Did this measure it in inches? So there you go. Okay? Yeah, you guys just don't forget to change degrees to radians. That's all you have to remember on that one. I'll answer one more if you want. Or we can move on. Okay, this assignment's due next time, so remember that. Okay, we are going to move on right here. All right, you guys, what we're going to do today is we're going to graph the sine and the cosine functions, okay? So I want everybody put down your pencil and look up here. I need you to understand this, okay? Next time we come to class, we are going to do lesson 6-3. Today's homework is going to be graphing. We're going to graph the sine and the cosine functions. And when we are all done, I'm going to have you answer these questions about the sine function, but I'm also going to ask you to answer these same questions about the cosine function. I don't want you to write these down right now. What I'll do is I'll print them off for you and hand them to you later on, okay? Or it's actually probably in your book, and that's what we'll probably do. But I want you to read through them right now, because these are the questions we're going to answer about the sine function. Starting right here, how long is one cycle of the sine function along the x-axis? So in other words, how far does it stretch left and right, okay? In other words, from where to where does the function start and end along the x-axis? Okay, number 2, what is the domain of the sine function? Remember, the domain is how far it stretches left and right. Now, the first question was one cycle of it. This question is the whole function. How far does it stretch left and right? And what numbers does it take on? Does it take on all numbers in between? Okay, the third question, what is the range? It wants to know how far up and down it goes. Okay, so that's another question you're going to answer. Number 4, where are the x-intercepts located? So you're going to have to name a few of them. There's lots of x-intercepts on the sine function. You're going to go along and say where it crosses the x-axis. What points on the x-axis? Number 5, where is the y-intercept? It's only going to cross the y-axis one spot. You got to tell what the y-intercept is. Number 6, what is the maximum value of the sine function? In other words, what's the highest point that this is ever going to get to? And where is the maximum? Where does the maximum value take place? Okay, so where do they occur? What x values does the maximum take place at? And number 8 and 9 are kind of the same, except it wants to know minimum. Where's the minimum? What's the lowest point on the graph? And what x values? For what x values does that take place? Okay, so this is kind of gives you an overview of the questions we're going to look at: domain, range, maximums, minimums, x-intercepts. We're going to want to know that. Okay, so right now, this is what you're going to do. Everybody is going to have everybody has a piece of grid paper. I've already passed them out. And it's going to look something like this. And this is what I want you guys to do. I want you to turn them all. Can I borrow yours? I want you to all turn them this way. Everybody see? And I want you to find the very last vertical line over here. And I want you to count back from there, like this. So everybody watch me right here. We're going to start here, and we're going to count over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you're going to put, right there, you're going to put a y-axis. So it's going to be on the 13th line from the left because you didn't count the first one. Starting by counting over 1, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The reason I said 13 because we didn't count the very first one, okay? All right, that's your y-axis, if you want to label it that. You guys all should know what it is by now. Okay, now for your x-axis, just somewhere close to the middle. Because there should be plenty of lines if you just do it somewhere close to the middle. Wait. You turned your paper the wrong way. Oh, well. Okay, there you go. All right, gotcha. Okay, now here's the x-axis. Okay, now we are going to, everybody get out your unit circle. Sit it down in front of you. You're going to need it. Okay, now just somewhere in the middle on one of the lines. Yeah, that looks good. Did you count over 13? Then you're right. What else is there? Okay, you guys, on your unit circle, we are going to mark at 0, 0, put a 0 along the x-axis. In the first line, we're going to do every 30 degrees, but we're going to put the radian measure. So pi 6, then pi thirds, then pi halves, and so forth. So like right here. Okay, so here's 0. Here's pi 6, then pi thirds, then pi halves. Yeah, I want you guys to label your graph like this. Okay, pi halves. What's the next one after pi halves?
Wait, isn't it 6?
You're doing every 30 degrees. We're at 90 degrees. So 2 pi thirds. Then 5 pi 6. Then pi, right? Has everybody got the pi?
Wait, no. So there's 6, 3.
We're going every 30 degrees, which is every 1/6 pi. So it's 1/6, 2/6, which reduces to pi thirds, right? 3/6, which is pi halves. 4/6, which is 2/3. 5/6, 6/6, which is pi. Well, it's sitting right in front of you, Callie. It's right here. Okay. You guys don't even need me for this. You guys got the thing. 7 pi 6. Yeah, keep going. Nope. 7 pi 6. We're not worrying about the pi force. Don't worry about the pi force, you guys. 8 pi 6, which is 4 pi thirds. 9 pi 6, which is 3 pi halves. 10 pi 6, which is 5 pi what? Thirds. And 11 pi 6. And then the last one is 2 pi. How we got that? Mason, you don't even know what this is about. Well, anytime something gets hard, then it's dumb, right? Okay. Guys, just so you know, anytime something gets hard in life, it's dumb. Okay? So we all accept that. Let's move on. Okay? Nicole. What? I did, didn't I? They're all reduced. I said some of them, but I said the reduced amount for. Okay, now, you guys going in the negative direction. I want you to go as far as you can in the negative direction. It's just going to be the same thing, but you're going in the negative direction. So the first one is negative pi 6, and then negative pi negative pi thirds, negative pi halves. If you want to write negative ditto, that's up to you. Negative 2 pi thirds, negative 5 pi 6, negative pi, negative 7 pi 6. Okay, we got that? You're not gonna get all the way to the end, I don't think. Does it? Some of your papers might. Did anybody's paper get all the way to negative 2 pi? It's all right if it doesn't make it all the way in. I would like to have done that, but it's probably not going to make it there on all of your papers. Okay, now I would like you. Every one going up is going to be 0.2. So that's 0.2, 0.4, 0.6, 0.8, and 1. Not 0.10. Okay? We're just going up to 1. That's it. And then we're going to also go down to negative 1. So negative 0.2, negative 0.4, negative 0.6, negative 0.8, and negative 1. Got it? Point 2, 0.4, 0.6, 0.8, and 1. Okay. So now we have this all figured out right here. Now I would like everybody to do this. Does everybody have a shoulder partner? If you don't have a shoulder partner, you're going to have to grab 2 pencils. But I'd like one part. We're going to do this in colors. So I'm going to pause it. Okay, pick one of your colors. It doesn't matter which one. Okay, each of you are going to have a color, and you're going to call that your sign function. So I'm going to write with my color up here, y equals sine of x. So everybody up in your upper left corner, write down y equals sine of x. Now, on a different sheet of paper, you're going to make an x, unless you want to do it on the back or something. You're going to make an xy table. Yeah, that's fine. Okay, you can do it on the back of this. You're going to make an xy table. Now, our x numbers are going to consist of these numbers that we have listed right here. So I'm going to start at 0, and I'm going to do the positive ones. I'm going to go 0, pi 6, pi thirds, pi halves, 2 pi thirds, 5 pi 6, pi, and 7 pi 6. And you guys, you'd continue this. I'm gonna do negative pi 6 too, so you guys know how to do them in the negative direction. Okay? This one doesn't need to be in a colored pencil, no. The graph needs to be in a colored pencil, so. Okay, now you guys are going to continue this, by the way. You're going to end up doing all of them that are on your paper. Okay? So we're going to start right here. Now, one thing that students always get confused when we do this, because remember, on our foldable, the definition we wrote for sine was the y value. And the definition for cosine is the x value. And everybody thinks that this x and y right here are the same x and y that's on the unit circle. It's not. Okay? Let me explain this to you. This x right here, anything that comes after a sine or a cosine or a tangent is an angle, right? So this x represents angle. The only reason we put an x and a y here is so that we can graph it. Okay? Usually we use theta for the angle, or alpha, or beta, or something like that. But we're using x right here, and it means the same thing. There's just a variable, but it's not the same variable as your points going around the unit circle. Okay? So what we're going to do is we're going to find the sine of an angle. Well, my first angle is 0. So I want you guys to all go to your unit circle. Everybody pick up your unit circle. I want you to look at 0 radians. And we want the sine of 0 radians? Well, the sine is the y value. So on all the sine ones, we're going to look at the y value. So what's the sine of 0, you guys? 0. So everybody put 0 right here, and then down here, plot the point 0, 0. Okay, right on the origin. I'm using green. What? You can use whatever color you want. Okay, pi 6. I'm going to go to pi 6. I'm taking the sine of pi 6. That's the y value, so it's 1/2. I would put it in as a decimal, 0.5. 0.5. So I want you to do this. Go to pi 6 and go to 0.5, which would be, does everybody understand? It's right there, halfway between 0.4 and 0.6. Okay? And then I want you to connect them. Okay? Then go to pi thirds. Pi thirds is right here. I want the sign again. It's always the y value. Square root of 3 over 2. We're going to convert that to a decimal. Everybody in your calculator, put square root of 3 divided by 2. Round it to the nearest hundredth. 0.8 what? 0.87. So everybody, go to pi thirds, comma 0.87, which would be, should be just, 0.9 is halfway between 0.8 and 1, right? So it's going to be just below that. Connect those. We're going to go to pi halves. What's the sign of pi halves, everybody? 1. If you go to pi halves, the y value is 1, so the sign of pi halves is 1. So you're going to go to pi halves, comma, 1. Okay? Then we're going to do 2 pi thirds. Well, guess what 2 pi thirds is? It's going to be 0.87 because if you go to 2 pi over 3 right here, the sine of 2 pi over 3 is square root of 3 over 2, just like on the other side, the pi over 3. Okay? And so we're going to go to 2 pi thirds, comma, 0.87. And then you're going to go to 5 pi 6. What's 5 pi 6? It's 1/2, or 0.5. And then you're going to go to pi. What is pi? The sign of pi. 0. Okay, now, you are going to continue all the way out to 2 pi. Now, I'm going to do 1 with you in the other direction. Negative pi 6. I need everybody to put down your pencil and watch right up here. On the unit circle, we don't have any negative angles, do we? But remember, we learned at the first year, to get a negative angle, you go in the clockwise direction, right? So instead of going up to pi 6, I'm going to go down that same amount, which is negative pi 6. It's the same place as 11 pi over 6, right? So the sign of 11 pi 6 is negative 1/2. So that's the sign of negative pi 6. So you go to negative pi 6, comma, negative 1/2, which would be right here, and you're going to connect it this way. Okay? So you're going to carry that out in both directions. Yeah. Yeah, I just forgot. Okay, hey, now, after you finish the sign, you're going to do the same thing with the cosine function. Switch colors, though. So switch with your shoulder partner when you're done. Okay? And you'll have both your sine function and your cosine function on that paper. And then save that paper. That's your assignment. And we're going to use it to answer your questions, those questions that I asked you at the first. Remember those? What's the domain? How long is one cycle? What's the range? What's the maximum? What's the minimum? And all that. We're going to answer those questions with it. So this is your assignment today. You got the last 10 minutes of class to work on this.